All right. Hello, everybody. My name is Veazey, and I'm going to be talking to you all about the auto cycle.
Open the door on the bottom. No, on the bottom of the black thing. Use the keyboard.
So I'm going to go over definition, the history behind who invented it, and the thermodynamic cycle, and talk a little bit about efficiency and applications. So the auto cycle is most commonly found in automobile engines. It describes the functioning of a typical sparking ignition piston. It basically answers the question scientifically of what happens when you have a mass of gas as it's subjected to changes in pressure, temperature, volume, and addition and removal of heat. It consists of isentropic compression, heat addition at constant volume, and isentropic expansion and rejection of heat at constant volume. So this is Nicholas Otto. He is a German engineer who first developed the Otto cycle. He was the first person to actually get a four-cylinder engine to work, which is pretty significant in the Industrial Revolution. He actually implemented the first completed engine into a motorcycle in 1876. So this is the process on temperature entropy graphs and pressure volume graph. And as you can see on the pressure volume, the green arrow, that's where it's going to start to intake. The mass of air, the working fluid, it's going to be drawn into the cylinder at a constant atmospheric pressure. And the exhaust valve is going to be closed during this process. And when it gets to point 1, the intake valve is closed, which is going to bring on the compression stroke. And this is when the working fluid is compressed inside the cylinder. And it assumes that no mechanical energy is lost and no heat is transferred to the gas, so the process is reversible. The next phase is the ignition phase from 2 to 3. And you can see there's a big rise in pressure and temperature. And this is all happening at a constant volume inside of that piston. The pressure ratio is measured as P3 over P2. It's called the explosion ratio. The next part of the process is the expansion stroke. It's isentropic expansion. And the increase in pressure from the previous process from 2 to 3 causes the piston to open, which releases that gas, the working fluid, and the pressure drops. So the volume ratio is, in this process, is also equal to the volume ratio in the 1 to 2 process. Next part is the idealized heat rejection. This is when the pressure drops from 0.4 to 1, and it's also a constant volume process. And this is when the gas returns to state 1. And then you have your exhaust stroke. And when the valve is open, the mixture is vented into the atmosphere at constant pressure, and the process starts over again. Here we just have some common variables used to analyze the auto cycle. You have specific heat at constant volume, specific heat ratio, pressure, temperature, volume, your fuel-air ratio, your fuel heating value, your cycles per second, power, and an important one is compression ratio. And at the bottom in the red box, you have your equation.